We now need to go ahead and learn about those imaginary numbers, those not real numbers. So the first thing I have on the screen is our imaginary number I. Our imaginary number I we define as equal to the square root of -1, which means that I squared is equal to -1. These two you have to know. So the square root of a negative gives you an I. And I squared will end up being the -1. We have something called imaginary units or imaginary part. So you'll have like a 3i or a -I. That part that has the I, that's imaginary. And so we've talked about real numbers. And so when we have our real numbers with our imaginary portion together, it makes up what we call the complex numbers. They're made of your real and your imaginary numbers combined in one. And the way we write that is a plus bi. A plus bi is a complex number. You have your real part, which we call a, and the imaginary part, which we call the bi. A can be 0 where you only have the imaginary part. B can be 0 where you only have the real part. But in general, we call that the complex numbers. And so when we say to write the answer in a plus bi form, that's how we write our answers for our complex numbers. First thing we have to learn about these complex numbers is how to simplify them. So now when we have our negative square roots, we'll be able to simplify them. First thing we're going to do is take out our i's. So when you see the negative square root, you take out your i's first. After you do that, you simplify as usual. So we have a couple of, about 3 or 4 examples to take a look at. Really 3. Okay. So the example says it's simplify. Number 1 is the square root of -4. I see square root of a negative. I immediately take out my I. And I write it right in front because that's really I times the square root of 4. So I take out my I immediately. And so the negative comes out in front of the radical in the form of an I, and it's no longer underneath the radical. So now you have I square root of 4. Now I can clean up my square root of 4 the same way I would before. Square root of 4 is 2, so I have 2i. And that's my answer. If I have negative square root of 4, that's not the same as the square root of -4. With the negative square root of 4, we just carry our negative down. And then we just handle that square root of 4 part. So those two are different. Make certain you understand the difference between them. One had the negative underneath the radical. One had it written out in front of the radical. So in number 2, we have 4 square roots of -8. I see a negative underneath the square root. I immediately pull out an I. And when I pull out my I write it right behind that 4. Just like we would write an X behind the 4, that's how we're going to write the I. So 4i square root of 8. Now we will need to clean up that square root of 8. My 8 is 2 times 2 times 2. So I have a set of 2's that I can take and write a 2 out front and leave a 2 out in the back in the radical. So I have that 4i times the 2 that I will be able to pull out, and I'll have the square root of 2 still there. So then the 4 times the 2 is an 8, so 8i roots of 2. And here's our last example. On here, it's very, very important that we pull out our i's first. If you do not pull out your i's first, you will not get a correct answer. You have to pull out your i's first. So we have negative square root of negative 3 times the square root of negative 27. So I pull out my I. So negative I square root of 3 times I square root of 27. Now, outside stuff, multiply outside, inside, multiply inside. Because our indexes match, outside times outside, inside times inside. So negative I times an I is a negative I squared. Then inside I'll have 3 times 27. And I'm not too worried about multiplying that because it's a square root, I'm thinking, how can I clean it up? So I have my 3, and 27 will end up being 3 times 3 times 3. 27 is 9 times 3. The 9 will give you 2 3s, and plus you already have a 3. So 3 times 27 becomes 3 times 3 times 3 times 3. I'm looking for sets of 2 because it's a square root. So here's a set of 3, here's a set of 3. So I have negative 3 times 3i squared. Notice I wrote the 3's in between the negative and the I squared, just like I would if it was a plain old x squared. So now the 3 times the 3 is 9, so negative 9i squared. We're not quite finished. I just want to go back and comment. If you would have multiplied the 3 times the 27, you would have had an 81. Then the 81, you can break up to 9 times 9 and get that same 9 that we have here. Or even break it up to the 4 3's to get what we had already. I squares, we can't leave those I squares there. I should have put a mark on here. Let's go back and add a comment. I squared is negative 1. That was part of our definition. So when I see negative 9i squared, that's not a finished answer. I have to finish it off. So that negative 9, the I squared becomes a negative 1. So I have negative 9 times negative 1, giving me a positive 9. That's my final answer. If you don't take out the i's first, you'll have negative 3 times a negative 27 underneath the radical to give you the positive 80 square root of 81. And you'll end up pulling out a 9, and there's already a negative there, and you would have a negative 9. It's a completely different answer. You have to pull out the i's first before you go into multiplying, or your answer is incorrect. So that's our first look at our imaginary numbers, where we're just simplifying the radicals to where we are getting that imaginary part, or our complex numbers, where we can turn around and clean those up instead of writing not real number.